This is chemical equilibrium. A chemical equilibrium talks about a state where there is no observable change in respect to what? To time. Or a chemical equilibrium can also be seen as a process by which the rate of forward reaction is equal to the rate of what? Backward reaction, which means they are both happening at the same time. They are happening simultaneously. So if I want to liken your mind, bringing the in economics to also explain what chemical equilibrium is, you were told that the law of demand and supply, that when the quantity demanded is equal to the quantity supply, the quantity that is supplied, we were told that both demand and supply are said to be what? In equilibrium. So in chemistry, when the rate of forward is equal to the rate of backward reaction, such reaction is said to be what? Is said to be what? In what? Equilibrium. Now, for us for instance, looking at the seesaw, when you have two children playing on a seesaw, one sitting at the other edge of the seesaw, another one sitting at the other edge of the seesaw, and the both of them are of equal weight, you find out that there will be a balance. There will be a what? A balance. But when the two children playing with the seesaw, when they're of different weights, you find that the other side will moving in the clockwise direction, while the other end will moving in the anti-clockwise direction, which means the seesaw will be unbalanced as a result of what? Different what? Weights that is being placed on the what? On a seesaw. Now, when you talk about equilibrium, to talk about equilibrium, there's what to talk about the open system and a closed world system. What is the open system? An open system are type of a system where one of where one of the reacting species, or where the reacting species are allowed to escape to the atmosphere. And such kind of reaction can be referred as what? Irreversible what? Reaction. Irreversible what? Reaction. Which means once the product is formed, the product can no longer react back to give us what? The reactant. Reason being that one of the reacting species have been escaped to the world, to the atmosphere. So another one we'll talk about what? The closed world system. A closed system is a type of a system where none of the reacting species are allowed to escape to the atmosphere. And such kind of reaction can be termed to be what? A reversible what? Reaction. And a reversible reaction, there are reactions where the reacting species have the capacity to react and give us backward reactants. And it is only in a reversible reaction that equilibrium can occur, because none of the reacting species are allowed to escape to the world atmosphere. Now, before I proceed, we will look at the properties of a system in equilibrium. I know there are numerous properties, but I'll mention a few. Number one, properties of a system in equilibrium. Such system must be in a dynamic world equilibrium, which means the rate of forward must be equal to the rate of what? Backward. Another one is that a catalyst have no effect on the position of what? Equilibrium. Reason being that a catalyst can only affect both the rate of forward reaction and the rate of backward reaction. For such, a catalyst cannot determine a particular direction that the equilibrium should shift. So that's the reason why a catalyst have no effect on the position of what? Equilibrium. Because immediately you bring in a catalyst will affect the both sides. The equilibrium will shift both left and right at the same time. Because what catalyst does is to speed up the rate of chemical reaction. Another thing again is that such reaction must be what? A reversible reaction. When talk about what? A system in the world equilibrium. The system must be what? It must be the closed system. So these are the properties of a system of a system that is what? In equilibrium. Now, before we proceed, to talk about the factors that affect the position of equilibriums, we'll look at what Le Chatelet principle states. Because you can't talk about anything that has to do with equilibrium without mentioning Le Chatelet principle. Le Chatelet principle states that if an external constraint, such as temperature, pressure, and concentration, are being imposed to the position of equilibrium, that the equilibrium will shift in order to annul or neutralize the effect of the change that be imposed to the position of what? Equilibrium. Now, the effect of this change could be temperature, could be pressure, it could be what? Concentrations. So when you now look at the factors that affect the position of equilibriums, number one factor is what? Temperature. Number two is what? Pressure. And number three is what? Concentration. These three things, these three factors affect position of what? Equilibrium. They determine whether the equilibrium can shift both forward or shift both backward or in any direction. These three factors can affect the position of what? Equilibriums. So that's what the young scientists, they call the Le Chatelet principle, was trying to prove, that in a position of equilibriums, if an external factors such as temperature, pressure, and concentration is being imposed to the what? To the position of what? Equilibrium, that the equilibrium will shift in order to neutralize the effect of the change that be imposed to the position of what? Equilibrium. Now, let me explain the effect or the factors that affect chemical what? Equilibriums. I will explain the effect of temperature. I will explain the effect of pressure. I will explain the effect of what? Concentration, using a chemical word equation. For most of the time, they will give you equation. They'll tell you what is the effect of what? Temperature. What is the effect of what? Pressure. What is the effect of what? Concentration. Sometimes they will ask you, increase in temperature, which side of the equation will be favored? Which side will the equilibrium shift? Sometimes they will ask you, decrease in temperature, which side of the equation will the equilibrium shift? So I will explain all that for you